Hi everyone, this is lesson 6.4 and today we're going to be talking about transformation of the sine function. So any sine function can be written in the form f of x equals to a sine times b in bracket x plus or minus c bracket close plus or minus d, where a is the amplitude, b is the period, c is the horizontal translation also known as the phase shift, and d is the vertical translation of the graph. When a is bigger than 1, then the graph will experience a vertical stretch. And when a is less than 1, the graph will experience a vertical compression. When b is bigger than 1, then the graph will experience a horizontal compression. And when b is less than 1, it will be a horizontal expansion. When c is positive, then there will be a shift to the left. When c is negative, then there will be a shift to the right. When d is positive, the graph will shift up, and when d is negative, the graph will shift down. Taking a look at example 3 from your learning resources. Consider g of x equals to sine x and f of x equals to 3 sine 2 in bracket x plus pi over 2 bracket close minus 1. The domain is x is less than pi but bigger than 0. So we can see the graph of f of x can be obtained from graph of x by doing several transformations. The first transformation is we have to multiply g of x by 3 to obtain this new function that has an amplitude of 3 rather than 1. Let's call this function h of x. So h of x equals to 3 sine x. Then we compress h of x by 2 to obtain h of x equals to 3 sine 2x. Next, we have to shift the graph pi over 2 units to the left. Since it's to the left, we have to add pi over 2 inside the bracket. And we get the following equation. Finally, we have to move 1 unit down, take the whole graph and move it 1 unit vertically down. And we'll get f of x equals to 3 sine 2 in bracket x plus pi over 2 bracket close minus 1. And that's going to be the final answer. And the graph will look something like this. It has an amplitude of 3, a period of pi. It used to be a period of 2 pi, but it got compressed, so now it's a period of pi. It moved pi over 2 units to the left side and 1 unit down. Let's take a look at the cosine function. The graph of the basic cosine function with an amplitude of 1 and a period of 2 pi is shown below in the slide here. Taking a look at example 1, graph the first cycle of the function f of x equals to 4 cosine 3 times x minus 2 in bracket plus 3. To obtain from f of x, you have to follow the following steps. First, you have to multiply the graph of g of x by 4 to obtain this new function that has an amplitude of 4 instead of 1. Let's name this new function h of x. So h of x equals to 4 times cosine of x. Then we compress h of x by 3 to obtain h of x equals to 4 times cosine 3x. Next, we take h of x and we shift it horizontally to the right by 2 units. Since it's to the right, we have to minus 2 in bracket. Finally, we move the whole graph 3 units upward, and since it's upward, we have to plus 3. Therefore, the final equation is f of x equals to 4 times cosine 3 in bracket x minus 2 plus 3. And the graph will look something like this, with an amplitude of 4, a period of 2 pi over 3, a horizontal shift of 2 units to the right, and a vertical shift of 3 units upwards. So that's the end of this lecture. Remember to do your activities as well as assignments and upload them for the teacher to mark. And I'll see you guys next time.